All right, in this video, we have this trigonometric equation over here, and we want to prove that 4y plus d squared y over dx squared, which is just the second derivative of this equation. If I add them, it's going to equal to 0. So I want to just start by finding the first derivative of this equation, dy over dx. So the derivation of 3 sine 2x is 3 cos 2x, and then by the chain rule, I'm going to multiply this by the derivation of the inside. Derivation of 2x is just 2, and then the derivation of 2 cos 2x is negative 2 sine 2x times the derivation of the inside, which is just again positive 2. I can simplify this a bit. 3 times 2 is 6, so I have 6 cos 2x minus 2 times 2 is 4 sine 2x. I guess I don't need a bracket over here. I don't know why I put it for these, but not necessary. Now I want to find the second derivation, d squared y over dx squared. So if I derive this, is negative 6 sine 2x, then times the derivation of the inside, which is another 2. And over here, it's going to be negative 4 cos 2x times the derivation of the inside, which is another 2. Again, I don't know why I put the bracket there. Keep negative 6 times 2 is negative 12 sine 2x. Here it's negative 8 cos 2x. And then I want to just sub this all into this equation and prove that it equals to 0. So 4 times y is 4 times the original equation here, which is 3 sine 2x plus 2 cos 2x. And then I want to add the second derivative, which is this over here, negative 12 sine 2x minus, I don't know why I have an 8x here, it's just an 8. 8 cos 2x. And now I just want to get rid of my brackets. So I'm going to multiply 4 into this bracket and the plus into this one. So I have 12 sine 2x plus 8 cos 2x. And then here it's just minus 12 sine 2x minus 8 cos 2x. And what you notice is 12 sine 2x minus 12 sine 2x just cancels off. 8 cos 2x minus 8 cos 2x cancels off. And we're just left with 0. So we've proved this equation over here to be true. Let's go to the second question over here. It's a similar one. I have 3 sine bx minus a cos 2x. And I want to find the values of a and b such that this equation is true over here. So again, I'm going to do the same thing. I'm going to derive this. So I'll start with dy over dx, and the derivative of 3 sine bx is just 3 cos bx times the derivation of the inside bx, which is just b. And then the derivation of negative a cos 2x, it's going to become plus a sine 2x times the derivation of the inside, which is just 2. I can simplify this a bit. 3 times b is 3b, and of course bx. And then a times 2 is 2a sine 2x. Now I'm going to find the second derivative. So d squared y over dx squared. If I derive this over here, I'll get negative 3b sine bx times the derivation of this, which is just b. And over here, if I derive this again, I'll get plus 2a cos 2x times the derivation of the inside, which is again 2. simplify this a bit. So negative 3b times b is negative 3b squared sine bx. And then 2a times 2 is 4a cos 2x. Now that I have this, I'll sub this into this equation over here. I know y is just the original equation there, which is 3 sine bx minus a cos 2x. And then I'm adding the second derivative, which is this over here. So I'll actually just put a subtract, because plus and minus make minus. Sine bx plus 4a cos 2x. And this is all going to equal to 6 cos 2x. Now, if I look at the left side and the right side, the sine terms don't really exist over here. And the cos terms are going to have a solution over here. So what you can do is, well, technically we can combine like terms over here. We have two like terms over here that we can combine. That's the first thing I'm going to do. 3 sine bx minus 3b square sine bx plus 3a cos 2x, because 4a minus a is just 3a. This equals to 6 cos 2x. So now if I compare the two sides, there's two sine terms here, but there's no sine term here. So I know that 3 sine bx minus 3b squared sine bx must equal to 0. And over here, I know that there's only one cos term on each side. So 3a cos 2x must equal to 6 cos 2x. Now I just have to solve each of these individually over here. I'll start with this one over here. I'll just move the b square, 3b square sine bx to the other side. And I'll just divide both sides by sine bx. So I'll just get, these will cancel and these will cancel. I'll just get 3 equals to 3b square. I'll divide 3 by 3 on both sides. So I get 1 equals to b square. Then I'll square root both sides. So I get b equals to plus or minus 1. And then to find a over here, I know that I can just divide both sides by cos 2x. So I get 3a equals to 6, and if I divide both sides by 3, I get a equals to 2. So these are my solutions for a and b. For a, I only have one solution, but for b, I have two solutions, and those will make this equation up here true.